Hello, bachcho. Hi, students. Welcome back to the class. So today we're going to talk about the applications of the theorems we have already discussed. So the application would be, today we'll try to solve the questions. We'll attempt exercise 1.1. And the first question is, express each number as a product of its prime factors. So we'll take the first number, that is 140. And because it says as a product of its prime factors, so the first prime factor could be 2. So we'll go 2 7 ja 14 and 0. Then we'll go 2 3 ja 6 and remainder 1 goes to tens place. So it becomes 10. 2 5 ja 10. Then 35 cannot be divided by 2. Simple reason is the digit 5 is not a even digit, it's an odd digit, right? So the next number would be 3. So it's again not going to be divided by 3. So we'll try 5. 5 7 ja 35 and then 7 1 ja 7. So the prime factors of 140 would be 2 multiply 2 multiply 5 multiply 7, or we can write it down as 2 raised to power 2 multiply 5 multiply 7. Cool. So the next number would be 156. So we'll do the same thing with 156. Let me just erase this. Cool. So we'll try to do it with 2. 2 7 ja 14 and then 1 goes here, becomes 16. 2 8 ja 16. Again with 2 because it's again even at a 8 is an even digit. So 2 3 ja 6 and 1 goes to the tens place, so becomes 18. 2 9 ja 18 and then it's not going to be divided by 2. Let's try 3. 3 1 ja 3, 3 3 ja 13 and then 13 is a prime number. So will be completely divisible by 13. So 156 would become 2 multiply 2 multiply 3 multiply 13, or we can write it down 2 raised to power 2 multiply 3 multiply 13. All right, students, let's attempt the third number, that is 3825. So 3825, because we know unit place digit is 5, it won't divide by 2. So let's try 3. 3 1 ja 3, 3 2 ja 6, remainder 2 goes to tens place, becomes 22. 3 7 ja 21 and then remainder 1 goes to tens place, becomes 15. 3 5 ja 15. Again with 3. So 3 4 ja 12, 3 2 ja 6, 3 5 ja 15. And then the next number would be 5 because it's not going to be divided by 3. So 5 8 ja 40, remainder 2 that goes to the tens place, becomes 25. 5 5 ja 25. Then again we'll divide it by 5. So 5 1 ja 5, 5 7 ja 35. 17. So 3825 can be written as 3 multiply 3 multiply 5 multiply 5 multiply 17, or 3 raised to power 2 5 power 2 multiply 17. So that'll be your answer. Cool. So we'll just slide it a little bit above and then we'll pick up the next number. Next number is number 4 is 5005. So we'll first attempt it by 5 because we obviously know we are the intelligent bunch of people. We're not gonna attempt it with 2 or 3. It'll be 5. 5 1 ja 5, 0 0 5 1 ja 5. And now the next number. Next number cannot be 5 because the last digit should be 0. The tens the units place, or 5. It is not. Then we'll try the next number, next prime number, that is 7. So we'll say 7 1 ja 7 goes remainder 3 becomes 30. 7 4 ja 28, remainder 2 becomes 21. 7 3 ja 21. So now it's not divided by 7. The next prime number is 11. Let's try with 11. 1 ja 11. Remainder 3 becomes 33. So it's 13 1 ja 13. So prime factors of 5005 becomes 5 multiply 7 multiply 11 multiply 13. So basically this is your answer. All right. Cool. So our last number is 7429. I really want you people to actually try this last number, but let's do it here. It won't be divisible by 2, 3, 5, 7, 11, 13, and the number that can divide it will be 17. So 17 4 ja 68. 68 means remainder is 6. So 17 3 ja 51. Remainder is 11. Becomes 119. So the number would become 17 7 ja 119. All right. So we know it's not going to be divided by 17. So the next number in the prime sequence is 19. So let's try it with 19. So 19 2 ja 38, and 38 5 goes here, and 19 3 ja 57. So the number would be, the next number in the sequence that can divide it would be 23. 1 ja 23. So we can say 7429's prime factors would be 17 multiply 19 multiply by 23. So this is how we have attempted our question number 1. Now go quickly on to the question number 2. Okay. तो बच्चों second question क्या कहता है? Find the LCM and HCF of the following pairs of integers and verify that LCM product HCF equals the product of the two given numbers. And we have already studied that for two numbers, the LCM and HCF of the product of LCM and HCF of those two numbers equals to the product of the numbers itself. It is just asking us to verify that, but before that we need to find the LCM and HCF. So 26, let's do the prime factors, would be 2 multiply 13. For 91, the prime factors would be 7 multiply by 13. So nice and easy. We know the LCM is all the prime factors. So we'll take all the prime factors and their highest powers. So their powers are 1, 1, 1, 1. We can also say that. So this is also the LCM, right? So LCM becomes 2 multiply 7 multiply 13, which comes as 182. Now the HCF. HCF is the highest common factor. And if you see, 2 is not common across two numbers. 7 as a factor is not common across two numbers. Only 13 is, right? So essentially we can say this is the HCF and this is the LCM. So if we multiply, let's say A is 26 and B is 91. A multiplied by B becomes 26 multiplied by 91, and this will be 2366. And if we multiply HCF by LCM, then it would be 182 multiply 13, and that will come as 2366. तो हमने ये भी वेरीफाई कर लिया कि दो नंबर्स का प्रोडक्ट उनके LCM और HCF के प्रोडक्ट के इक्वल है, right? So this is the verification method that we have used here. Now the next number, we'll pick the next number. Next numbers are 5, 10 and 92. So let's take the factors. So the method is same. You go with the basics, right? And then you can find the factor of 510. So that will come up as 2 multiply by 3 multiply by 5 multiply by 17. And the factors for 92 would come up as 2 multiply 2 multiply 23. right? So nice and easy. We'll calculate LCM. So for LCM, we'll multiply all the unique factors. So factors are 2, 3, 2, 3, 5, 17, 23, 5, 17, 23. And the maximum power for 2 is 2, 3 is 1, 5 is 1, 17 is 1, 23 is 1. So the LCM would be 4 multiply 3 multiply 5 multiply 17 multiply 23. And the answer for this would be 23460. I'm sure you guys can do the calculation, right? Next, HCF. So the HCF is the highest common factor. Which one is the common factor? 17 is not, 23 is not, 5 is not, 3 is not, only 2. So 2, and we take the least power. Least power is 1, that comes here, because in 92 it is 2 raised to power 2 multiply 23. So HCF is 2. Now if we, let's say A is 510 and B is 92, so A multiply B would become 510 multiply 92, and the answer would be 46920. Similarly, if we multiply HCF by LCM, 23460 multiply 2, then the answer would be 46920. All right, so this is how we can prove the else we have verified on these two numbers. Cool. So the next pair for us is 336 and 554. So we'll take down the third number. 336 and 54. So 336, if we take the factors, so it will become 4 times 2 multiply 3 times 7, right? And for 54, it will be 2 multiply 3 times 3, right? So nice and easy. HCF, if we calculate HCF, we will put down the common prime factor. So the common prime factor here is 2, and the other number is 3, and we need to take the least power, right? So the least power for 2 is 1 here, and 3 is for 3 is again 1. So the HCF becomes 6, and LCM would be, we note down all the prime factors, 2 multiply 3 multiply 7, and we'll take their highest powers. So the highest power of 2 is 4, highest power of 3 is 3, and the highest power of 7 is 1. So it becomes 16 multiply 27 multiply 7, that comes up as 3024, right? So again, for verification, you just multiply 3024 by 6, you will get the number as 18. Why the pen is not working? 144, and the same, if you multiply these two numbers, you're gonna get this final number. So this is a very basic question. I'm sure board will hardly ask this question. They might ask, maybe they can ask this question, but this is not a strong contender to be part of your board examination. Cool. So let's attempt the next question. And the next question says, find the LCM and HCF of the following integers using the prime factorization method, right? So the formula that we have just used, that formula says the product of LCM, the product of numbers itself is equal to the product of LCM and HCF, but that is applicable only for 2 numbers, not more than 2 numbers. Now हम LCM and HCF calculate करेंगे 12, 15 and 21 का. तो for 12 we'll note down 12, 15 and 21. So the prime factors, because we have to apply the prime factorization method, so the prime factors would be 2 multiply 2 multiply 3, and prime factors would be 3 multiply 5, and the prime factors would be 3 multiply 7, or we can say 2 raised to power 2 multiply 3, or this can be written as 3 multiply 5, or this can be written as 3 multiply 7. I've just written it in this sequence just to show you how easy it is to calculate HCF with this method. So HCF, which one is a common digit? Common digit is 3. So HCF becomes 3 because the highest power is 1. So it's 1 and becomes 3. LCM, for LCM we'll mark all the prime factors, 2 multiply 3 multiply 5 multiply 7, and if you see the power of 2 is 2, otherwise power of all other numbers is 1, so it will become 4 multiply 3 multiply 5 multiply 7, and if you multiply all these numbers it will become 420, right? So this is basically pretty easy, straightforward question. I'm sure you guys can do it easily. You don't need to follow this video for it. But let's cover the second question. 17, 23 and 29. So you know, I mean 17 itself a prime number, 23 एक prime number है, 29 एक prime number है, 17 can also be written as 1 multiply 17, 23 can be written as 1 multiply 23, 29 can be written as 1 multiply 29. So highest common factor is clearly 1, and LCM would become 17 multiply 23 multiply 29. And when you multiply all these numbers, the final number would come as 11,339. So that'll be your answer. Okay, so let's attempt the third and the last question for question number 3, the last sub question. So this is 8, 9, 25. So if we factor 8, 2 to ja 4 to ja 8, or we can write it down as 2 raised to power 3. 9 is 3 multiply 3, or we can write it down as 3 power 2. 5 multiply 5, or we can write it down as 5 square. So we clearly know this is also, we can write it down like this. So HCF will be 1 and LCM will be 8 multiply 9 multiply 25. So that's your LCM, and that LCM will become 1800. Okay, bachcho, so let's move on to, without wasting any time, let's move on to the next question. So the next question is this. Cool. So it says, given that HCF of these two numbers 306, 657 is 9, find LCM. So we know we can also write it down like this. We can say for any given numbers A and B, product of A and B equals to the product of LCM and HCF, right? Or vice versa. So we can essentially write down, they have given the HCF. So HCF is 9 multiply LCM equals the numbers itself, 306 multiply 657. So LCM would be 306 multiply 657 divided by 9, right? So we can say 3 times, 4 times, and 34 multiply 657, and this will be your answer. So if you multiply these two numbers, the number would become 20,000, 200,042, right? 201,042. So that's your answer. Cool. So we have also attempted this question. Actually, questions of this exercise are not that hard. I'm sure you guys can attempt it yourself, but we can also solve them together. Cool. Now, the next question. It says, check whether 6 raised to power n can end with the digit 0 for any natural number n, right? So we know, I mean, we have gone through the fundamental theorem of arithmetic, and it says any composite number can be written as a product of prime numbers only in one unique way, right? So to do that, what we can say, first step for us should be find out the factors of 6. So the factors of 6 would be 2 multiply 3, right? 2 times 3. Or we can say 2 raised to power n multiply 3 raised to power n, right? That is also equals 6 raised to power n. So now the next thing would be, in order to prove that this digit will never end with 6 raised to power will never end with the digit 0, we know we need to write down condition for a number to end with 0 at units place. There are two conditions, right? First off, a number ends with 0 means it's divisible by 10, or the prime factors for a number to be divisible by 10, it must have 2 and 5 as its factors, right? Then only the number can be divisible by 10. And if you match these conditions against the factors of this number, you can see 6 raised to power n has 2 prime factors, 2 and 3. But the condition says it should have 2 and 5 both as the factors. So our conclusion would be, as 6 raised to power n does not have 5 as a factor, it can never end with digit 0, right? So that's pretty easy to prove. Now, without wasting any time, let's go on to the next question. So what is our next question? Next question is very easy. It says, explain why 7 multiply 11 multiply 13 plus 13. So these two numbers are the composite numbers, right? So if you remember, in the last classes, we have already discussed that the composite numbers can be written as a factor of prime numbers in one unique way, right? And for a number to be a composite number, it should have a factor that is different than 1 and the number itself, right? So we just need to prove the number that comes after this calculation will have a factor that is not a number itself and that is not 1. So our first number is 7 multiply 11 multiply 13 plus 13. So what we can say, we can take the common part 13 and it can be written as 7 multiply 11 plus 1, or it can be written as 13 77 plus 1, or 13 multiply 78, right? So that's what this number says. So if you look at this number has got more factors than 2, or essentially, I mean, all the books talk about if the number has got more factors than 1, then that number is a composite number. But I would say if you look at this, it has got more than one factor, 13 and 78. So you can clearly say, since 13 and 78 are both greater than 1 and the expression is a product of these two numbers, so this expression is a composite number. So we can say is a composite number, because what basis we have applied? We have just applied the definition of a composite number. So composite number definition fulfills for this expression. So hence we can easily prove this number is a composite number. Similarly, we need to do it for the other expression as well. So the other expression is 7 multiply 6 multiply 5 multiply 4 multiply 3 multiply 2 multiply 1 plus 5, right? So if you look at this as per the BODMAS rule, so this is one part, this is the second part, right? So what we can do, we can take 5 as common, and then it will become 7 multiply 6 multiply 1 multiply 4 multiply 3 multiply 2 multiply 1 plus 1. And if you multiply all these numbers, that will come as 5040 plus 5. So it will be 5 multiply 5045. So again, since 5045 can be expressed as 5, maybe we can write it down, 5 multiply 1009. So and both 5 and 1009 are greater than 1. So also you can write it down as like this. So we can say 5 and 1009 are greater than 1. So as per the definition of composite number, this expression becomes a composite number. Clear? So this is just in some cases you have to apply the definition of the composite numbers. Sometimes you have to go by some theorems. So that's how you solve these questions. But I'm sure these are very, very simple questions for you guys. Cool. Okay, so hamara next question. Okay. So let's not move this. Cool. So it says there is a circular path. So let's say there's a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same location. So we need to find out after how many minutes they will meet. For all these questions, what you need to do, because if you actually visualize this problem statement, it says after how many minutes, because both are running at a different speed, and after how many minutes they will meet at a point. So what we need to do, we need to pick their total times that they're going to take to complete one circle. We need to find the LCM of those two numbers. That's it. That will be your answer. And if you visualize, that will be like a least common multiple. So the first meeting point would be the least common multiple of the time taken by both Ravi and Sonia to complete one circle, right? So Sonia takes 18 minutes. So 18 would be 2 multiply 3, and Ravi takes 12 minutes. So there'll be 2 multiply this will be 2 multiply 3, and this will be 2 multiply 3, or we can write it down as 2 multiply 3 raised to power 2 or 2 raised to power 2 multiply 3 raised to power 1. And now you guys know, can someone tell me how you calculate the LCM of these two numbers? Come on. So to calculate the LCM, you write down the unique factors and then you just put the highest powers. So highest powers are these 4 multiply 9 and 36. So it says after 36 minutes, they will meet at one point. So 36 minutes means once Sonia completes, after it completes 2 circles, then that's where Ravi will meet Sonia. Right? So that's actually concludes exercise 1.1. And now in the next lecture, we can move on. We can understand the more and more concepts. I think the next section is about irrational numbers and how you can prove the numbers are irrational itself. Because in class 9, you guys have learned about what are the rational and irrational numbers. But in mathematics, sometimes you need to also prove if something is something, then why something is something. So this is pretty brain involving exercises that you need to do. That's how you actually grow with mathematics, right? But that will be very simple. I'm sure the journey I'm gonna take you guys on, you would definitely start loving mathematics. You would definitely love mathematics and you won't be scared of mathematics. That's my promise to you. Okay, so that's it for today. Hope you guys have learned something today, and these exercises, just go back to your books, read the books, solve the questions. Don't just rely on these videos because these videos not gonna help you 100%. It's just gonna give you some guiding path. Rest depends on you, right? Cool. Till next time, see you guys. Bye.